Your outboard left the factory with its power deliberately strangled. Rev limits choking 5.7 horsepower. Fuel pressure caps starving combustion by 7 pounds per square inch. Timing tables pulled 3 degrees below peak. These aren't defects. They're restrictions engineered in for emissions compliance, noise regulations, and product tier pricing. 10 hidden limiters are buried inside your engine right now, and undoing them costs as little as $45. But one risks a $37,000 federal fine. Charlie's 2019 Mercury 250 sits tied to the dock, idling at factory set limits. The spec sheet promises 250 horsepower, but the engine's computer draws a hard line at 5,800 RPM. That ceiling isn't mechanical, it's programmed. A $250 flash tool, sold by a half-dozen marine tuners, rewrites the rev limiter and lifts the cap by 300 RPM. On the dyno, Charlie's engine jumps by 5.7 horsepower, measured at the shaft. The torque curve shifts up across the top end, enough to shave 2 seconds off a quarter-mile sprint. But there's a catch. The service bulletin for Mercury warns that any tampering with the limiter voids the powertrain warranty. If the crankshaft lets go, Charlie's on the hook for repairs running $2,200 to $4,500. Ivan, a Gulf Coast fisherman, runs a 200 horsepower 4-stroke. He's tired of the engine stumbling under heavy load. His solution costs less, $120 for a bypass kit that raises fuel pressure by 7 psi, pushing the system from the stock 45 psi to 52 psi. The result? A 4.2% torque boost logged on a handheld dyno and a 2.5% jump in peak horsepower. Full throttle fuel burn ticks up by 1.9%, but at cruising speed, the extra consumption is barely noticeable. After the bypass, Ivan's engine pulls cleanly even with a full catch. The onboard computer, though, flags a fuel pressure code. The dealer calls it a non-approved modification and logs a recall. Both tricks work by sidestepping factory restrictions, one at the RPM ceiling, the other at the fuel rail. The cost difference is clear: $250 for a digital override, $120 for a machined restrictor. The gains are real, but so are the risk. NMMA regulations cap prop shaft RPM for inland lakes, and any pressure change that pushes emissions out of spec can trigger EPA scrutiny. For Charlie and Ivan, the choice is simple: more power now, or play it safe and leave horsepower on the table. The pattern is set, mechanical tweaks, measured results, and a wallet comparison that makes the next round of tricks even more tempting. Mike's Tohatsu, built for tournament sprints, runs a stock ignition map until a $300 flash tool unlocks 3 extra degrees of timing advance. The numbers show up instantly. Peak power climbs by 3.4%, torque hits earlier in the rev band, and the boat leaps out of shallow water with a sharper punch. On the dyno, exhaust gas temperature rises by 22 degrees Fahrenheit, a clear sign the combustion event is hotter and more aggressive. Mike's crew logs a 3-minute advantage per race, enough to turn a $45 tweak into real prize money. But the service bulletin is blunt. Push timing past 12 degrees before top dead center, and the warranty is gone. One cracked piston crown, found after a season, gets flagged as over-advanced ignition, no coverage, full repair bill. Dave's Honda BF-115, a weekend workhorse, suffers from a common lag: throttle response that stumbles off idle. He picks up a calibration kit for $45, resets the throttle position sensor from the factory 0.5 volts to a true 0. Throttle lag drops from 340 milliseconds to 210 milliseconds, a 38% improvement. The engine snaps to attention, especially when loaded with gear. Dave's fuel log shows a modest 0.4% drop in consumption at cruise, thanks to a leaner mixture on rapid transitions, improving efficiency. The fix is cheap, the reward is immediate, but the dealer's warning is clear: Any non-factory sensor alignment can trigger a throttle system fault, and the next out-of-range error could mean a denied warranty claim. Laura's Evinrude E-Tech faces a different dilemma. She installs a custom stainless exhaust bypass, opening 20% of the cowling port to cut back pressure and free up scavenging. The result? A 2.9% horsepower gain, about 7 extra horses, and a 2-knot bump at top speed. But the sound pressure at the transom jumps from 90 to 96 decibels, blowing past the NMMA's 94 decibel inland limit. Within months, Laura receives a $150 noise citation. When a crack develops in the exhaust housing, the dealer refuses warranty service, citing the unauthorized mod. The bypass delivers speed, but the price is steep. A $1,200 warranty void and a permanent risk of legal trouble. For every mid-range gain, there's a new line to cross: more power, sharper throttle, louder exhaust, and a growing list of risks that follow each shortcut. Sam's Suzuki 165, docked high in Colorado, faces a problem most coastal boaters never see: power loss at altitude. At 1,500 feet above sea level, the air is thinner, and the factory map sensor tells the ECU to pull back fuel, aiming to keep emissions in check. The result is a 4% drop in horsepower, noticeable every time Sam tries to get his boat onto plane. A $260 ECU remap, loaded with an altitude-compensated fuel map, brings that power back. On the water, Sam logs a 6-horsepower gain, measured with a shaft dyno. Acceleration improves, and the engine stops running rich during long runs. Fuel consumption at cruise drops by just over 1%. A small but real savings across a summer of fishing. The catch? Suzuki's own service memo warns that remapping for altitude voids the emissions warranty. When Sam files a claim for a fuel pump leak 6 months later, the dealer points to the modified map and denies coverage. Meanwhile, Tom's racing hull on the Chesapeake is already tuned for speed, but the hull fights him as the water gets choppy. Factory trim tabs, set at neutral, are designed for all-purpose stability, not outright performance. Tom installs an adjustable hydraulic kit for $180 and dials in an extra 5 degrees of positive tab angle. The bow drops by over 1 degree, reducing lift-induced drag and letting the hull ride flatter at speed. GPS logs show a 0.8 knot increase at a steady 30 knots, with fuel use dropping by 1.5% at cruise. Over a 150-hour season, that is about $45 saved in fuel, modest for a casual boater, but decisive for a racer chasing every advantage. The manufacturer's engineering note warns that pushing trim beyond 6 degrees can overstress the transom and void hull stability coverage, but Tom keeps his adjustments within the safe range. For both Sam and Tom, the numbers are clear. Environment and geometry aren't just background conditions. They're levers for free speed and recovered power, often left untouched by dealers and ignored in factory settings. Greg's Gulf DF90 idles in the heat, a dozen miles off the coast, with the prop loaded and the sun beating down. He's lost count of engine stalls during summer charters. The fix is a set of $22 shims for the idle air control valve, raising the idle from the stock 650 RPM to 800. The change is immediate. Idle speed climbs by 23%, stalls drop off, and the engine stays running even as the tide turns rough. Across a season, Greg spends less on starter repairs and avoids the $75 average cost per heat-struck engine. The fuel burn at idle ticks up, but the extra 0.03 gallons per hour barely registers on the ledger. Maria, running a tropical charter with her E-Tech, faces a different battle: overheating. She installs a high-flow water pump housing for $420, swapping out the stock composite for a larger, smoother aluminum casting. Flow rate jumps by 15%. After a full throttle run, coolant temperature is 9 degrees lower. Over 2 years, Maria logs a 20% drop in heat-related service calls. The engine runs cooler, seals last longer, and the risk of a $3,000 head gasket repair shrinks. For both Greg and Maria, these tweaks mean more uptime and fewer frantic calls to the dock. But reliability is only the prelude. Nate, a former OEM software engineer, takes the next step with a CAN bus ECU remap, a firmware rewrite that unlocks the factory's hidden horsepower. For $450 to $750, the remap alters fuel enrichment tables and torque limits. On a Yamaha 250, the dyno reads a 12% jump in peak horsepower, about 30 extra horses, and a 9% surge in mid-range torque. Fuel use at cruise falls by 3.2%, and diagnostic trouble codes drop to half their previous rate. The power is real, but so is the risk. Any unauthorized firmware change voids the emissions warranty, and EPA penalties for emissions violations can reach tens of thousands of dollars per engine. Nate's move is bold. He's chasing performance the factory left locked away, but the legal and financial exposure is massive. One wrong code, one flagged emissions test, and the cost could exceed $37,500. For owners willing to gamble, the power is there. For everyone else, the line between smart tuning and legal trouble has never been thinner. Right now, every outboard on the water hides untapped potential, sometimes as much as 30 extra horsepower and a 10% drop in fuel burn, locked behind factory code. The edge belongs to those who question the baseline. The real limit isn't the engine, it's how far you're willing to go.